Okay, here's some more practice for 2.4 and 2.5 with properties and proofs. So the first part, use the given property to complete each statement. So the addition property equality is when you add the same thing to each side. So if I add 3 to each side, I'll get 4x equals 13. Transitive property. If angle TQM is congruent to x, and angle x is congruent to angle LTS, you can basically cancel out the middle parts. Therefore, angle TQM is congruent to angle LTS. Number 3, name the property that justifies this. So why is the distance between TM equal to the distance between QR, and then the distance between Q and R is equal to the distance between T and M? Well, all we did is switch the left-hand side and the right-hand side. So when you switch the left-hand side and the right-hand side, it's called the symmetric property. And number 4, if 4t plus tq equals 4 and t equals q, then 4t plus 2t equals 4. So if I look at both of these circled red equations, the difference is I have that this one's 4t plus tq, this one's 4t plus 2t. So the difference is we've substituted q and t. So this is the substitution property. So I write substitute or substitution. Number 5, if 5x equals 6y, then what happened with 5x over 2 and 6y over 2? You're dividing both sides by 2, so it's the division property of equality. And number 6, if 4x minus 2 equals 6, why does 4x equal 8? Looks like all we did was just add 2 to each side. So this is the addition property of equality. Number 7, name 2 pairs of congruent angles in each figure and justify your answers. Okay, I know that angle 1 is congruent to angle 3 by the vertical angle theorem. It says 2 pairs. So angle 2 is congruent to angle 4 as well by the vertical angle theorem. Number 8, I know that angle 2 is congruent to angle 3 by markings. See how these symbols right here mean they're equal in measure, or they're congruent. And I also know that angle 1 and angle 4 have to be congruent because they're supplementary to congruent angles. So this is called the congruent supplements theorem. That's why angle 1 and angle 4 are congruent. Number 9 is similar. I know that angle 1 is congruent to angle 4 by markings, and I also know that angle 2 has to be congruent to angle 3. That's by the congruent complements theorem. Congruent complements theorem. And I know here that angle 1 and angle 3 are congruent. So I'm going to write angle 1 congruent to angle 3. I also know that angle 1 is congruent to angle 2. So this is a transitive property. By transitive property, I can cut out these angle 1s. Therefore, angle 3 is congruent to angle 2 by the transitive property. Okay, also make sure you know how to fill in proofs. So the first line, how do I go from, algebraically, 1 to 2? To go from 1 to 2, I did the distributive property. So I write it on line 2, distributive. To go from line 2 to 3, I added 16 to each side. So on line 3, I'm going to write the addition property of equality. To go from line 3 to 4, I divided both sides by 6. So I'm going to write the division property of equality. Okay, now let's look at the second proof. So sometimes I usually write conclusions right here and justifications, but you can also see it as statements and reasons. It's the same thing. So we're going to fill in the reasons for each one. So the first one, why do we know that the measure of angle GEF is equal to 90? Well, that's up here in our given, so I'm going to write given. Same with this one. That's given. How do we know that the measure of angle 1 plus the measure of angle 2 equals the measure of angle GEF? Okay, I just realized that I did not have a diagram for this. So I drew in a diagram. The measure of angle GEF is 90, so I'm going to mark it. Always mark up your diagram. The measure of angle 1 is equal to the measure of angle 3, so I marked that up. And now I'm on line 3. So why does the measure of angle 1 plus the measure of angle 2 equals GEF? That is by the angle addition postulate. So next line, why does the measure of angle 1 plus the measure of angle 2 equals 90 degrees? So if I look at line 3 and line 4, I need to see how I'm going from line 3 to line 4. What is different between the two lines? We each have measure of angle 1 plus measure of angle 2, but the difference is one has the measure of angle GEF, another one has 90 degrees. So can you look higher up to find anything else? If you look up here, look, these two are equal, so that means I substituted, instead of writing GEF, I wrote 90, so it's called substitution. Now let's look at from line 4 to line 5. Okay, I have these two parts are the exact same, but the difference is measure of angle 1 and measure of angle 3. So how I know that measure of angle 1 equals measure of angle 3 up there. So that means I must have substituted down here. So again, it's substitution. And that's it. Okay, let's practice another one of these. So the first line, why is the measure of angle 1 equal to the measure of angle 3? Well, that's given, so we can write given. That's 1. That corresponds with this line. I'll draw these lines in so it'll be easier to see. And then 2. Why does the measure of angle EBA, so I'll mark it over here, equal to angle 3 plus the measure of angle 2? Well, measure of angle 2 plus measure of angle 3 is equal to the blue one. So that is by the angle addition postulate. And number 3, why? Number 3 and 2, again, are very similar. The difference is I have a 3 instead of a 1. So if you look up here, I know that 3 is equal to 1. So I must have substituted. So substitution. And number 4, why is angle 1 plus angle 2 equal to DBC? So DBC is this right angle. That is also by the angle addition postulate. And the last one, why do we know that EBA is equal to angle DBC? This is another case of you have this, look at line 3 and 4 up here. The same thing's happening where you have angle 1 plus angle 2. But this time, this one's equal to DBC and this is equal to angle EBA. So that means that we substituted EBA in right here for measure of angle 1 plus the measure of angle 2. So again, I'm using substitution. For these types of problems, what we're going to do is solve for x by setting up an equation that shows the relationship between the angles. So right here, this is 180 degrees. So I know that 7x plus 2x plus 27 has to equal 180. Because this angle plus this angle adds up to 180. So then I would go through and finish off and solve for x. Now this one right here, these two are vertical angles. So we know by the vertical angle theorem that their angle measures are equal. So I'm going to set 3x plus 12 equal to 5x. And then I could go ahead and solve for x. So 12 equals 2x, x equals 6. So if I plug in 6, this angle measures 30. And therefore, this angle has to be 30. Okay, next one. The relationship between all 4 of these angles is that they have to add up to 180. So this arc right here means that this angle is also 4x minus 5. So I'm going to have 4x minus 5 plus 4x minus 5 plus x plus 7 plus 4x plus 1 equals 180. And then I would solve for x. And the last one is, if this is 90 and this makes a line, that means that this is a 90 as well. So my equation is this angle plus this angle has to equal 90. So it's 2x plus 7x minus 9 has to equal 90. And you go ahead and solve for x.